Hi! So today we're going to talk quickly about describing the motion of an object using Newton's first law of motion. In this review we're going to go over some quick definitions, some examples, and then I want you to really listen carefully to the big misconception. First of all, definitions. In order to understand this very first law, the law of inertia, it's important that we take a look at some important definitions. First of all, let's take a look at the definition of mass. Mass is simply a measure of how much stuff is in an object. So we can be thinking about this in terms of atoms or molecules or just even matter. To measure mass, we use the unit kilograms. Now, mass is very different than weight. Weight is really just the effect of gravity on a mass. And we measure weight in newtons. If you'll recall from your reading, newtons are simply a measure of how much force it takes to move a 1 kilogram object 1 meter per second. Now, to calculate the weight of an object, we use mass multiplied by the acceleration of gravity. Now, the reason I'm emphasizing this is that mass is not the same thing as weight. However, mass is directly connected to inertia. Inertia is how much an object resists changing motion. Now, by what I mean by how much an object resists changing motion is all objects have a certain amount of matter, and it requires a certain amount of force to speed them up, slow them down, or cause them to change direction. How much that object resists those changes is its inertia. So, for example, if you have a ping pong ball or a large boulder, the ping pong ball will have less inertia, whereas the large boulder will have more inertia. Both of them will resist changes in motion in that they both have mass, but the ping pong ball will resist it significantly less than our large boulder. So, now that we have those definitions, let's take a look at Newton's first law of motion, which is also called the law of inertia. Newton's first law of motion says that an object in motion will stay in motion at a constant velocity. An object at rest will stay at rest unless acted on by an outside force. There are 5 things that I want you to keep in mind. First of all, this first one, an object in motion will stay in motion. This means that an object that is moving will continue to move without any additional forces being acting on it. Now, that is only true if this second thing holds, which is at a constant velocity. Now, a constant velocity says that it is moving in a straight line and that it is moving at the same speed all of the time. If it is not moving at the same speed, there has to be an acceleration involved. If it is changing direction, there has to be an acceleration involved. If neither of those things are happening, then your object is moving at a constant velocity. Now, the third thing is that an object at rest will stay at rest. This is also stating, and one of the most easily observed, that objects that are not moving will tend not to move unless acted on by an outside. Now, outside is an important part of this because the outside part says that it is an unbalanced force. Now, this is important because if I have an object that is moving along and it is acted on by another force, but that force is balanced, there still will not be any change in my object's motion. So it's very important that you remember that the force that will cause a change is an outside and unbalanced push or pull. So here are some examples. We have a cup. Yes, I know, lovely drawing. We have a cup that is sitting at rest on an object, like a table. Now this cup is going to remain in this position forever unless another force acts on it, causing it to speed up, slow down, or change direction. Now, slowing down would simply be an indication of a direction. The other situation is when we have an object that is already moving, and as long as there are no other outside forces acting on it, that object will continue moving in a straight line at a constant speed forever and ever. Now, why don't we see this on Earth? Well, that has to do with misconception. The big misconception that we see in physics is the idea that all objects require forces to keep them moving. Now, this is an idea that was first presented by Aristotle back in ancient Greece. And Aristotle simply said that if you see something moving side to side, it had to have a force acting on it. Now, we found out through the work of Galileo and then later on with Newton that that is just not true. That an object does not require a force in order to keep moving. That is where we get the idea that an object in motion will stay in motion in a straight line and at a constant speed. Now, why is this such a big misconception? Well, because we live on a planet where there are constantly forces acting on any object. For example, we have air resistance. Any object that is thrown inside our atmosphere is going to encounter that air resistance. And that air resistance is going to slow down an object, so we never actually see an object moving without another force acting on it. Also, we live in a gravitational field, and that gravitational field causes objects to be accelerating towards the center of the Earth at a rate of 9.8 meters per second every second. Now, do these facts negate Newton's first law of motion? Well, of course not. They just help us to understand what we observe. So, here are the key ideas. Objects do what they were doing. So an object at rest will stay at rest. An object in motion will stay in motion. Now, this only occurs when our forces are balanced. So if the net forces, or the sum of the forces acting on the object, are in equilibrium, objects will continue to do what they were doing. Now, remember our big misconceptions. Forces are not required to maintain an object's motion. If all of that makes sense, you've got Newton's first law of motion.